Hello, my name is David Onion. I work in the University of Nottingham's flow cytometry facility, and I'm the facilities manager. So the University of Nottingham's flow cytometry facility is the university's established centre of excellence, and we work with about 150 researchers every year. And we work right the way across the board with a wide variety of applications. So right from model organisms such as zebrafish, bacteria and yeast. And of course, we have the more traditional users of flow cytometry, immunologists, cell biologists, and cancer biologists. We also collaborate with other universities, particularly in the Midlands Innovation, and we work also with external companies. So we've been using the Sony ID7000 to develop a 22-color panel to measure SARS-CoV-2 specific T cells. So all in one assay, we've been able to look at cells responding, so looking at their cytokine response. We've been able to look at their phenotype, so particularly their memory phenotype. And we've also been able to look at activation markers as well as markers of senescence and exhaustion. And the key thing really was for us to be able to develop that assay rapidly with conventional reagents of conventional fluorescent antibodies. So we were able to build that panel quickly and then apply it. And now we're starting to get really rich and deep data. So we chose spectral technology because it gives us the ability to resolve really highly overlapping fluorescent dyes. So it makes combinations like Alexa 4647 and APC doable together, and even things like GFP and YFP. And it's enabled us to do highly multiparametric panels. So we're now doing panels of 20 and 30 colors together. And it's really given us the flexibility to utilize lots of different applications in one machine. So we've had the ID7000 for just over a year now, and we originally introduced it through webinars, but our regular users have been swapping over to the ID7000 when they come across new projects, and they haven't looked back. We've been able to train just over 50 users to be fully independent, so they can operate the machine right from startup and QC to running their samples and turning off the machine at the end of the day. So we see the high capability analyzers as a real step change. It's taken from what used to be a difficult experiment to something that's now easy to do, and those panels that were impossible to do to something that we can do readily in the lab. So we think spectral technology is likely to replace conventional flow cytometry in the future, not only where you've got high color panels, but also to gain that high sensitivity and that flexibility, particularly in a core facility.